Now we already started using some physical models. Let's have a specific conversation about that now. When students use physical models for measuring, it's really helpful for them to understand what the measurement actually means. This is a really important part of early measurement. And for the most part, for things that students are measuring in pre-K, first and second grade, there are usually hands-on tools that students can use to measure most attributes. And we can think about using different types of tools. We can use non-standard tools as well as standard tools. So let's talk about that briefly. Now, non-standard units are items that are really not standard for measuring metric units or US customary units. And often we use non-standard units when we begin measurement instruction. So some things that you might consider for non-standard units of measurement are popsicle sticks or toothpicks. You could see how many cans something is, or maybe you could use these Legos to figure out how many Legos in height or how many Legos in width. There's a lot of different ways that we can use our non-standard units, and all of these ways that we use our non-standard units will help us support understanding of attributes and the importance of specifying units. One other example, which I use quite often, are paper clips. That's a really good non-standard unit of measurement. Now then we move to standard units of measurement. So these are standardized either metric system units or US customary units. Some of the standard units that students might focus on in the early elementary grades include the following. So if I'm working on time, standard units include second, minute, hour. If we're working with measurement of length or height or width, we might be using a centimeter, an inch, or a foot. If we're thinking about how much something weighs, we might be talking about an ounce, a kilogram, a gram, or a pound. If we're thinking about measurement of temperature, a standard unit there would be in degrees, typically degrees Fahrenheit. And then if we're thinking about what the volume that goes into a container, such as you see there, we might be measuring in cups or fluid ounces. So what are the goals for student understanding of standard units? Well, students should be familiar with standard units. This is going to help with their estimation of those standard units. And students should be able to interpret meaning of measures given in standard units. For example, if I'm measuring the height of this can, I could think about that in centimeters to see that this can is about 15 centimeters in height. So what does that mean? Students should be able to interpret that. As students start to work with physical models, students need to learn about tiling. That is, that we can use as many copies of the unit as needed to fill or match an attribute that is being measured. So, for example, I'm trying to figure out the footsteps from one door to another door, so I can tile my footsteps. I could use as many copies of that footstep as needed to move from the first door to the third door. That's a non-standard unit of measurement with those footsteps, but that's a really nice example. Maybe I'm trying to figure out the area of this desk, and I'm using these index cards to figure out how many index cards fill the area of the desk. So there I tiled the index cards. So not only did I just use one index card to figure out the area, but I figured out that this desk has an area of about 12 index cards. Another good example of non-standard units of measurement. Now, tiling differs from iteration. Here's where I use a single copy of the unit to then figure out how to measure something. So maybe I think about this desk and I want to figure out the length of this desk in index cards. I'm going to go back this example so we see it again. So I'm going to iterate. I'm going to use that index card once and then move it over twice, move it over a third time, move it over a fourth time. And if I keep track of those counts, the length of this desk is 1, 2, 3, 4 index cards. Now, iteration isn't always easy for students, so I'm going to talk through some iteration difficulties as we look at some real-life objects. Now let's talk about iteration. I want to figure out the length of this hammer, and I only have this one ruler right here. So I need to iterate this ruler to figure out the length in inches of this hammer. So one of the things that's sometimes tricky for students is I say, okay, I have this ruler here, and now we're going to move it along. And if they don't have a strategy for keeping track of their iteration, they'll just move it over here, and then maybe I determine that, well, that's about 16 inches or so. It also might be difficult to remember that this ruler was 12 inches, and then I'm counting on 13, 14, 15, 16. But that's not actually the length of this ruler because I did not iterate very well. So I'm first going to think about, well, the distance from the very end of this hammer, so that I line that up with the 0 on my ruler, over to here is 12. And I'm going to put my finger there. So then I remember that I'm going to start right there at the tip of my fingernail for the next set of 12. So far the ruler is 12 inches long, and then I scoot this along, and then I say that it's 13, 14 inches long. So that ruler was 14 inches, which I was able to figure out by the act of iteration. As we start to measure, there's something that students might encounter that they might think is weird, and that is that smaller units will produce larger measures. Let me give you some examples of that. Here are some different measurements. So I can see that I'm measuring the height of this board here. So that might be 1 yard, or maybe it's 4 index cards, or maybe it's 5 markers, or maybe it's 12 of these things right there. Now, it's funny to me that a smaller unit actually ends up with a larger measure. That might be a little bit counterintuitive. So that may be something you want to talk about with your students so that they don't get confused when they see, oh, that took 5 markers. Well, that doesn't make sense because this yardstick is longer. Well, it actually does make sense if we know that smaller units produce larger measures. Now, I would like you to push pause right now and think about non-standard units. We talked about those non-standard units as well as standard units. And I would like you to consider which non-standard units would be important for your students to use.